Yes, this is our first video on the axiomatic thermodynamics, and we would start the videos in this way that we first define what our variables and what our basically all the different terms are, and then we will slowly get into the theories and the formulas that we know as we know of them. So first off, which is something that's very, very important in thermodynamics, is the definition of a system. And one can understand a system in a way that it is a body which can be separated from the surroundings. So it can be a body of matter or a body of radiation. It just has to be separated, has to be able to be separated from the surroundings, and it will have then a boundary also between the system and the surroundings. So let's write it first. It is a body that can be separated from the surroundings, and it can be used to then study the laws of thermodynamics. So we basically, what we have here is something like this. If we have a system which is basically a body of mass or radiation, as we said, inside our perceivable universe, so like more of like a surrounding, and we also have a boundary that separates the system and the surrounding. Obviously, when we have also defined the system, we should also be defining what actually a thermodynamic state is. Yes, like the word state, it comes within quantum mechanics, in mechanics in general, also thermodynamics, and it seems to be also a very important definition at first, because it kind of describes a lot about a system. It actually describes the condition of the system at a specific given a specific set of variables. So it is actually very important for us to first define what this state is. Officially, the definition would be something in the lines of that it is the condition of a system at a specific time, which is then fully identifiable by certain parameters. So like let's first write it. Thermodynamic system, thermodynamic state is the condition of a system at a given time which is described by certain sets of parameters. So these parameters could be temperatures, these parameters could be pressure, energy, etc. What these parameters could be, or what these variables are, they also have a bit of difference given what kind of variable one is perceiving. Exactly, so we also have such difference in variables. And what are these variables actually called? What are these parameters actually called? These are called the state parameters, or the state variables. The state parameters. These are parameters which define the state. Defining the state of a thermodynamic system. Right. And there are certain sets of such state parameters. We can have either extensive ones or intensive ones. So what is the difference between these? The difference is pretty simple, I would say. The extensive state parameters, they are dependent on the size of the system. So as you increase the size of the system, you generally increase also the values of those extensive state parameters. So it is proportional to the size of the system, while intensives are really not. So here there is no proportionality with the size. What could be examples of such systems, of such state parameters? We can maybe consider volume. We can consider energy. We can also consider the number of particles in a system, if of course there's a constant flow. And then by intensive state parameters we can consider maybe pressure, because pressure does not necessarily increase or decrease given the size of a system, and also its temperature, the absolute one. We can also take chemical potential, for example, of intensive state parameters. Exactly. And we also have the definition of a thermodynamic process. It is basically the change of the state of a system. So we also have thermodynamic process. These are again, these lead to a change of the state of a system. We can also obviously have different thermodynamic processes, like different types of thermodynamic processes. Here there is also a difference between reversible and not reversible. Right. And as the name also suggests, of course I changed the position of L and E, sorry for that. What the difference is between such reversible and not like irreversible processes is that, as the name again suggests, in a given instant you can reverse the process. It's not only but that, it also would mean that the state of the system is defined at every instant that one is measuring or observing the state. Exactly. So in an instant, it is in an equilibrium. And in not reversible ones, you do not, like, the system state changes very fast. An example would be, let's say we have a process whereby P and V, so like pressure and volume, are being changed. And you have, let's say, you start off at a point A, and then you slowly start moving to another point, which is point B. Between these 2 points, if you can find that the state is, so the state function, this is basically a function, this red line, it is basically a function, and this function tells us that it is continuous between the points A and B. and therefore you can find the state at each such point in that instant, and therefore the information of the path that the system has taken from state A to B is completely known, using those variables, using those parameters. So it can be considered as reversible, while let's say the other process, the irreversible one, basically only knows the values of the parameter that we are measuring of the state A and B, and in between we do not know anything. These points basically mean that there is no line, so we do not really know anything about it, so it is irreversible. Because we do not know how fast, like it is not really, it is continuous, it might be continuous, it might not be continuous, but we do not really know the information. It was not really that in every instant that there was an equilibrium. So whenever you see like a stage or an abrupt change of the parameter during a state change of the system, then it must be reversible. Right, so that's about it for this video. I hope I could explain a bit of the fundamentals that would lead us to more and more theories in thermodynamics in the later videos. Thank you.